All right, so we're starting Unit 4 today, which is all about probability. We'll spend the next 4 chapters learning about probability. So I'm going to start you out with a basic definition you've probably seen before. Most people use a definition like this to define probability. The number of outcomes we want goes on top. The number of equally likely outcomes goes on the bottom of a fraction. Think of this as the total. So if I asked you to find, here's my little collection of shapes. Ooh, some interesting notation here. Giant P stands for probability. Whatever's inside the parentheses is what I'm looking for. So if I were to randomly select one circle, what's the probability that I select blue? Well, it's 1 out of 5. We can see that's because there's one blue circle out of 5 circles total. But a more technical definition that you're going to see in your textbook is that probability is a relative long-run frequency. Excuse me, long-run relative frequency. Long-run meaning if we do lots of trials. Relative frequency, right, thinking back to Unit 1, was like a percentage or a fraction. So what do we see over the long run? Well, we talk about the fact that a coin lands heads up 50% of the time. Not because if you flip a coin 10 times you get exactly 5 heads, but because in the long run, that's what happens. And there are other probabilities we can't figure out this way, so we simply observe what happens over the long run. Now, I made this fact up. I don't know if it's true, but perhaps the red light at 3500 South and 36 West, just down the street, what if it's red 35% of the time? Well, that means the probability of the probability of getting to the light when it's red would be 35%, because in the long run, that's how often it happens. So I'm going to start us out with some just really basic examples of probability. Number 1, because some of us have never seen it before, but number 2, I want to show you some rules, and it's easier to see when we start with really simple examples. So we'll go ahead and answer these questions. The probability of choosing a red shape out of these ones I have pictured on the side here. Well, we can see just by counting that there are 2 reds out of 6, so that's a probability of 2/6. Now, I know you're going to ask me, Ms. Curtis, should we reduce that fraction? Well, of course you should, but I'm not going to bother with that today in my examples because I want to focus on the probability mathematics, not on our fraction skills. All right, so next question says, what's the probability we get something that's not red? Well, I do have students who come over and they say, oh, well, this one's not red, this one's not red, this one's not red, this one's not red. And we count it and we find out there are 4 objects that are not red. But some students, I've noticed, describe it this way. They say, well, 2 are red. If there are 6 total, I just subtract. That means 4 things are not red. That is actually a rule. It's called the complement rule. Not complement, you look really nice today. Complement meaning opposite. If I want to find out how many things are not red, I would take my total, right, 1. I can think of that as 6 shapes out of 6 shapes. And I would subtract, write this technically, I take 1 and I subtract the things that are red. Okay, I don't want those, so I'll subtract them away. So this is 6 out of 6 minus the 2 6 that are red. That leaves me the 4 6, which is the same answer we saw here. So complement rule, that's going to be helpful to us. All right, 2 other facts that I want to point out. The probability we select a shape, well, 6 out of 6, that's 1. That's as high as the probability can go. And just for fun, I'll stick in an extra problem here. What's the chance that I get a green shape? Again, I'm just choosing from these we see pictured off to the side. Well, Ms. Curtis, there are 0 green shapes, so that's a probability of 0. So probabilities have to be between 0 and 1. Okay, we can't go negative and we can't go above 1. Think 1 like 100%, right? That's really as high as you can go. Don't listen to those lies on TV that say, time to give 110%. You can't do that. All right, just 2 more rules. Again, I know these are really basic, but I want to point out how they work while we have really simple examples. So the next question is probability of red or yellow. Well, if I come over and actually count This thing is red or yellow, this thing is red or yellow, this thing is red or yellow, this thing is red or yellow. So there's 4 out of 6 shapes. But how we're going to handle our OR questions, or I guess I could say how we actually get the 4 6, we take the probability of red. There were 2 out of 6 things that are red. We take the probability of yellow. There are 2 out of 6 things that are yellow. And we're going to add those together. That's how we get the 4 6. Okay, so when we have something that's not as simple of a picture, or tells us to add. Okay, or tells us to add. And you can see why by looking at this picture. All right, what about the word and? Well, if I come back to my picture and I'm looking for something that is red and a triangle, it has to be both characteristics at the same time. Clearly, there is only one thing that is both red and a triangle. So the answer is going to be 1 6. So let's see how we could get that using reds and triangles. Well, if I take the probability of reds, there were 2 out of 6 reds. If I take the probability of getting a triangle, well, there are 3 out of 6 triangles. We're actually going to multiply these 2 things. That gives me a probability of 6 out of 36, which is 1 6. Same answer. So what we see here is that the word and tells us we're going to multiply. So if I could ask you to memorize 2 things in this unit, these would be the 2 things. Or means add, and means multiply. Or means add, and means multiply. Now, the rules that I'm showing you are simple, and they do only work in certain circumstances. And we'll get more into that in Chapter 15. So let me define a couple important words. Or means add only if the events are what we call mutually exclusive, or disjoint. Now, to help you understand what disjoint means, I want you to think about Venn diagrams. When things overlap, we consider this not disjoint if my 2 events overlap. For example, choosing AP Stat students and choosing female students. There are some that are both. But mutually exclusive, or disjoint, looks like this kind of Venn diagram. For example, blue shapes and red shapes. There's nothing in between. All right, our and, meaning multiply, our little rule only works when 2 events are what we call independent. The outcome of one trial doesn't affect another trial. Now, we're going to go a lot more in depth for independent in Chapter 15. But I just want you to kind of plant this idea in your brain now. We did actually see independent when we studied Chapter 3. But we'll come back to this a lot in Chapter 15. All right, so let's take a look at just a couple of examples that you might actually see these kinds of problems. Suppose that 40% of cars in Utah are manufactured in the U.S., 30% are manufactured in Japan, 10% in Germany, and 20% just come from other countries in the world. If cars are selected at random, find the probability that. Okay, and then we're going to answer 3 questions. First of all, a car is not U.S. made. That word not is a clue that we should use the complement rule. It says we take 1 minus. Well, I want things that are not U.S. made, so I'm going to subtract away the United States ones. Now, I know they've given us percents, but I prefer to work on my probability questions in decimals. So I'm going to do 1 minus. Well, let's see, 40% of cars are made in the U.S., so I'm going to subtract 0.4. That gives me an answer of 0.6. All right, 60% of cars are not U.S. made. What about it's made in Japan or Germany? Remember that word or tells us we're going to be adding. So I'm going to take the probability of cars made in Japan, and I'm going to add the probability of the cars made in Germany. Well, let's see. Japan was 30%. That's 0.3. Germany is 10%, that's 0.1. So my answer is 0.4. All right, and number 3, we see 2 in a row from Japan. Well, 2 in a row. That means I need to see a Japanese car and then another Japanese car. Aha. Japan and Japan. That word and, it's our clue we're going to multiply. So this is going to be the probability of Japan times probability of Japan. Again, let's see, Japanese, it was 0.3, so this is going to be 0.3 times 0.3, which is 0.09. Be real careful multiplying your decimals. And that's our answer. All right, just one more page. We have the American Red Cross. Says that about 45% of the U.S. population has what we call type O blood. 40% have type A, 11% have type B, and the rest have type AB. Now, type AB is not A times B. It's a unique blood type, AB. Someone volunteers to give blood. We're supposed to find the probability that this donor has type AB blood. Well, it might be helpful to remember that all the people in the United States would have to add up to 100%. Okay, that's our total, right? So I've already used 45% for type O. I've got 40% that have type A, and I have 11% that have type B. That means I'm up to 96% of the population already. So the rest have type AB. Well, what's left over? This is a complement rule. 100% minus 96%. That means I have just 4% left over that have type AB blood. All right, and I'm going to leave it to you to go ahead and try out numbers 2 and 3. Be sure to write down your work or your thinking. That will help us catch any mistakes and be able to answer questions about those.